Hey guys, what's up? Eddie Alho here with KissAnalog.com. Today, it's going to be kind of a cool video, or a hot one, whichever way you look at it. We're going to take this nice power, we're going to run it up to 300 watts, and we're going to look at the temperature across it. Actually, we're going to run it. So what I did, okay, here, let me back up. What I did is I ran this thing at 300 watts, and then I let it cool off a little bit because my loads were getting so hot. And then I fired it back up. I thought, hey, pull out my thermal camera and let's take some images. So I pulled out my X-Therm. So I'll put a link for this. And also there's a link down below where I reviewed this on a audio amplifier, I think. So anyway, another practical use case for it down the link. And then I kind of forget what I used that on for actually. Because I also did one. I got these thermal cameras all like boom, boom, boom. I got this TOPDON. Okay, both of these were sent to me for free, by the way, and I've done reviews on both of these cameras. But what I'm going to do in this video is I just want to show you this power supply, and I want to show you the thermals, and we're going to take a look to see how well it's designed. If the parts are actually oversized enough, they seem like they are. I didn't really see anything getting really hot. As a matter of fact, the fan rarely kicks on. So if you're not like a nice quiet power supply, 30 volts capability, 0 to 30 volts, 0 to 20 amps, this guy can kick out some power, and the fan rarely goes on. So we'll see in this video, because I've already done it once before. Fan kicked on rarely. I had that other camera on it. Okay, the X-Therm. I'm going to use a TOPDON today to bring it up to 300 watts. So you see both videos, and yeah, you can kind of see both cameras in action. Now, I'm not really showing them off very much because in both cameras you can add dots, lines, or boxes that in either one of those cases, it will, on the dot case where you put the little X's, it'll just tell you the temperature in those places where you put those. In the line case, it'll go up and down the line trying to find the hottest thing on that line, or the coldest thing. It'll find the hot and cold thing. And on the box, it'll run around the box, tell you the hottest, coldest thing in that box, which I think is super cool. And the combinations of those things are really neat. In this video, I'm going to make it simple. I'm going to make a line on each one so I can place that line where I want to see the temperature. And the resolution on these are crazy good, so I want to show you. By the way, a lot of the cameras, especially in the past, like I have this one too, which I've always liked this camera, but now that I've got these high resolution cameras, now they came out with a high resolution version of this one too, but this is a HTI, I think they call it. But anyway, I'll put a link down for this one in case you just want a one piece. I kind of liked this. Has a camera right there, but the new one, like I say, has high resolution, but the resolution when it's so high, unlike one like this where you have a regular light spectrum camera, normal camera with the thermal, and you can kind of overlay them on top of each other, there's some parallax error, right? Because the lenses are like this and they're kind of aimed this way, so you kind of have to adjust the two pictures, the two images, to get them on top of each other, line them up this way and this way. So it's much nicer and easier just to have a camera that you can move around. So anyway, let's come over here and take a look, and I'll show you what I'm talking about. All right, guys, sorry. One little quickie. It really helps with the YouTube analytics. It shows YouTube that people like the video or whatever. So if you give a thumbs up, a like on the video, subscribe, hit the bell to be notified of new videos, that really helps the channel a lot. Just want to throw that out there. Appreciate you guys. Let's get into the video. Alright guys, so I decided to take a video here with this X-Therm camera, and this thing is quite amazing. I was trying to see what temperature and what indicated to the unit to turn on the fan. So you can see that NTC right there. It is like 90, 100. Now I turned it off for just a moment and turned it back on. And there's this resistor over here. It's getting really hot. But look how great this camera is. You can actually see what the parts are below it. That combo choke is running cold. So a lot of these parts look like they're over designed, meaning they're designed to run cool, which is nice. Now if we look at here at the front, there's a microprocessor. It looks like it's hot, but it's really only, it's hot relative to things around it, but it's like 45 degrees. So it's raised 20 degrees, and you can see how the heat spreads around the board. And it's coming from, the power is coming from those aluminum electrolytes down below, because it looks like the heat, you know, it's kind of, the heat flows down to them. And yeah, the rest of the thing looks pretty cool. So when you look at the rest of the board, you see this control over here, the one that's running the main output. And I could focus this camera. Get my big fingers out of the way. Yeah, so right there I'm focused. You can see the parts around them. It's, you know, it looks hot. Again, relative to the things around it, it's like 40 degrees C, so it's running pretty cool. And then the wires, see my fingers here at the edge of the box. So the power wires are just between this and the board. Down there you can see them. And they are running very cool. So no problem there. Then we come to the connector back here. Camera's updating, and relatively hot to the things around it because everything's so cool, but it's only 30 degrees. So now we look at the heat sink and the aluminum electrolytes. Now if we go this way, you can see that thermistor is everything's referenced to that, so that's hot. That's like close to 100 C, and everything else is really cold. But if I get the camera out, you know, get that out of the camera's view, then everything else kind of gets relative hot. And so underneath the heat sink, you can see things around 44 degrees. Still pretty darn cool. That's a big heat sink, and I'm trying to get down here so you can see it. So yeah, amazing camera. And oh, by the way, there's the fan. It has been on and off, so it's warm. You know, it shows it's warm, but it's really only 34 degrees. So now if we look at the output it chokes, because we want to make sure they're sized. And if I go like this and get that thermistor in the shot, you can see how cool they are in comparison, right? And there's that resistor over there, and that resistor is about 95 C too. So the resistors, I would say they're undersized. I don't think we want to run that hot. So those two resistors are undersized, but everything else looks like it's oversized. So transformer is very cool. All the magnetics are very cool. And if we come over here, my load resistor, see I put another 200 watt resistor on top of it, try to help run cool, and it's still 87 C. So over here I have another resistor. So I'm running resistor on the output connector right here. You can see the wires going to it, and also on the input, just to try to get as much power out of this as I can. So by the way, this is 4 ohms in the back, so it's running a little hotter, 129, 130 degrees C. And again, I have a resistor sitting on top of it, so trying to help keep it cool. So yeah, there's the thermal. And here's the end of the other two. Kind of interesting looking at the color contrast. These cables look hot relative to the mat underneath them. They're only 31 C, so they've risen like 5 degrees or something like that, maybe 8 or 10 degrees. The front of the display, that's what we see, about 32. So yeah, there we go. Just thought we'd do a thermal, and the fan does kick on every once in a while and runs for not very long, less than a minute it seems like, and then it turns off. And it is blowing out, so it's sucking through the sides of the box. Here I can focus the lens now that I'm pulled away from the whole thing. Okay, there we go. So yeah, this is a great setup, I think. Yeah, I think this camera is a great camera and really kind of an interesting rig, but works great. And you just see the definition in there. Some cameras have to have a photo that they put on top of the thermal because the thermal resolution is just not good enough. But this thermal resolution is so good, you can see all the little parts. Pretty amazing, huh? I'm pretty impressed. This thing really well designed, over designed as far as everything can handle all the power, because I've got 140 watts right now, so I guess I'm only about half power, but it's because I was up higher. Like I was up around 220 watts, I guess, and then I just turned it down because the resistors were getting so hot. So everything runs just so cool in this thing. Even at max power, they didn't really warm up that much more. So I'm going to turn it down, let things cool off. But yeah, I guess I could put a full load on there, right? I could tie all 4 resistors up to it and really load it down and do that. So maybe I should do that. But I just wanted to show you how it looks like this thing's so pretty well designed as far as the size of components. Okay guys, so we're running at 300 watts output. There's the inductor, doesn't look too hot. The thermistor looks like it's getting pretty warm. And the resistor, transformer looks pretty cool. Resistors over here look hot. And how about the inductor? Inductor's like what, 38 under 40C? So the inductors don't look too hot. Fan has not kicked on yet. But you can see underneath this thing, it's about 40 something C. And there's a look across the board. This TOPDON camera is pretty awesome. Very similar to the other camera. This one kind of autofocuses, kind of. Let me see how close I can get. I don't know if I can focus quite as close, but otherwise it kind of autofocuses. There's the PTC, because we're running, oh, the camera had readjust. So we're running this load out here, and it is getting pretty darn hot. I can smell these things, of course. These things are really hot. About 100 watts on this side, and about 200 watts on this 300 watt resistor. Pretty cool resistor, right? It's a non-inductive resistor. It's counter wound to counter the inductance. This thing actually works better as non-inductive resistor than this one. And there's a power cord. Let me see how hot that is. It's only about 30C. So let's see the wires running down along the side. So the power running down along the side here. Now the fuse in there gets a little bit warm just because it's a resistive element, right? But it's still under 30C. It's 28C or something. And then we see the wires run up here. Let's go look at the output wires running up to the front of the panel. They look pretty cool too. So if I try to get the thermistors out of the screen, well, there's the capacitors. They're like 33C, 34C. Okay, right there, there's the control chip for the flyback. And one of the diodes looks like it's running fairly hot. And the fan just kicked on. So we're down here on the board around 37C. There's the control chip there. My resistors are getting really hot, so I think I'm going to cool this thing down. All right, just turn down the load. But yeah, thermal cameras are pretty awesome because you can catch things like those diodes down there that are getting kind of warm, right? Those diodes might be a little, let me see how hot they are. They're like 48 something C, but you know, I kind of believe in sizing the diodes so they don't get hot. The fan already kicked off. It seems like the fan does not run unless you know, I mean, unless the board gets really hot. I'm not sure where the thermocouple is yet. I haven't found that. I haven't really actually looked for it. But somewhere on the board, there's going to be a thermocouple that's telling when the fan to turn on. Now, I can see a diode right here that's a little bit warmer than the other diodes. If I put this line across it, it's like 30C. So it's just relatively hot compared to things around it, but it's not really hot. That's probably true with these diodes up here too. They're like in the 40, high 40Cs maybe. So yeah, I thought that might be interesting. Run this thing at 300 watts and see if anything gets hot. And it seems like it runs fairly cool. Now, of course, the lid's off, so we're not getting, I mean, we're allowing some, you know, some natural airflow, which isn't much, but at least some convection. All right, guys, so what do you think? That's pretty interesting, right? It's kind of cool to compare the two cameras. And yeah, the TOPDON. I'm going to have to do a full review on this camera because it's super nice. But yeah, the other one was Xtherm. It's just this little cube right here, and it has that focus lens, and it has this whole gizmo holding it all together. But yeah, this thing is yellow. It's sitting inside this little holder there, so I can clamp it in. Anyway, I've done a review on this one. I'll put that down below. But these cameras are nearly the same price, I believe. And yeah, both really nice. I'll put the links down below. What do you guys think? Pretty cool? Pretty hot? I mean, it is running pretty cool. I'm going to do a video showing how you can get rid of this noise. Yeah, if you can see on the screen right there, it's not a really great image with all the reflections, but I'll do a video. That's the noise. I'll show you how I got that on the screen. And we'll see what we can do about improving this. Okay? All right. Okay, guys, the fan is on. We got 570 watts, 31 volts. So the fan's on. I've got one 4 ohm load there, one 4 ohm load there. They're tied together to make 8 ohms. Over here I have two 8 ohms making 4 ohms, and then there's 4 ohms. And that 4 ohm resistor is getting much hotter than everything right now. So things are heating up, but it took just a couple minutes before the fan kicked on. And you know, I smell things getting heated, and it almost smells like silicon, if you know what I mean. So here, I'm going to change the color palette on this one. That's interesting. See the resistor, nothing's really getting hot. It's only showing the hot parts on this one. So that's interesting. There's a green palette. They call it Jungle, Aurora, and this is Infiray. Yeah, that's pretty interesting, that resistor, right? Those resistors, 60C, they're starting to warm up. Over here, we're still running pretty cool. I didn't want to, you know, max out the front panel. That's why I did it that way. Okay, let's go to another palette. That is Iron Red. Okay, 500. Oh, hold on a second. We current limited because we're down to 0. Let's see what happened. All right, guys, it shut off, and it's only been 5 minutes, 20 seconds now. And so let's see what happened. Okay, it came back up. It's 568 watts, 570. So it thermally shut off. Interesting. Here, I'll start videotaping again. And I'll put the little line right on the cord. It's like 37 degrees. So yeah, it's only warmed up like 10 degrees. So everything's kind of relatively hot, right? You know, when you see it that way. Here, let's go to rainbow. Okay. Trying to see which one I like better. That's called black hot. So what's black is hot. It's pretty much the same stuff at 300 watts, right? The fan's running continuously. That's the difference. Let's try white hot. Now everything that's white is hot. Kind of like the black hot. Iron red, aurora, jungle, and this is golden red. Oh, okay. So how hot is that? That heatsink over there is like 85C. We're really hot on that resistor, like super hot. It's giving me warnings. The cameras even give me warnings. So maybe I should shut down. It looks like the loads are the ones that are getting hot. Okay, so I turned it down, turned the power way down. We've been running about almost 8 minutes, 7 minutes, 50 seconds. So that shiny surface over there on that potentiometer, that kind of fakes out the camera. You need to put some black tape, electrician's tape, or some kind of tape on these things to kind of darken them up, the shiny surfaces, like this heat sink, for instance. So all right, well, so I have some black tape over here, and the hot spot, you know, the hot spot's only like 49 degrees, but it is cooling off because I turned off the load. So it did get quite 600 watts though. All right, guys, I'm going to let this fan cool things down for a minute. And I have this, by the way, I put this plastic top on to kind of limit some airflow. There's really no airflow in the lab here, but you know, just to kind of try to box in the heat a little bit. And then I took it off and I started using the thermal camera. So I left it on after the fans had kicked on before I took it off. And then they're still on now. So, and you know, at first when things heated up, it almost smelled like semiconductor. Like I almost think that those resistors, I'm just wondering, it could be my load resistors, but I smelled it before my resistors really started showing the heat. So I don't want to say it's burning in because you shouldn't burn in things, but it almost smelled like, I don't know if it was a resistor on the board or something getting hot before the fan was able to cool it down. But all right, so hey, there we go. Interesting, right? Seems like this guy will put out the power, 570 watts. I guess the real test would be to put the cover back on, get some more load. So that guy, this is a 300 watt load, this long green one. These two 8 ohms that I have in parallel to make 4 ohms, roughly the same. And also this 4 ohm, I think it's like 3.9. But these two guys making 4 ohms, they're like 400 watts. So that's why they could, you know, and also those kind of resistors, the heating element's buried inside. So it takes a little while longer for the heat to get out. Where on the screen one, it's just a filament with this, what is it? It's some kind of oxide finish that they put on top of these things for voltage isolation. and it works really great for high temperature. Oh, whew, and the fan turned off. So I may have filtered out that fan noise so you didn't have to listen to it, okay? Or at least I might let you listen to a little bit of it so you can see the level of the noise, and then I will probably try to filter it out if I can. All right, whew, okay, that was a good test. And by the way, I like to let the fan turn itself off before I turn off the power, because I don't want just everything staying hot and cooling with stagnant air. I like to use the fan to, you know, I don't know if you've used one of those overhead projectors. They kind of operate on that method automatically. You turn off the power, the fan will stay on until it cools it down and it turns itself off. So when you're running this kind of thing on your bench, same thing. Once you're done running power to whatever you're running, leave it running for a while. You know, you can turn down the voltage and current and everything, but just leave the fan running, let things cool down. Okay? All right. Whew. All right. Hey, thanks for watching. And it's just a quick thermal thing just to show you performance and so on. But 2 thumbs up to my patrons as always. 2 thumbs up to all you guys watching the videos and all that. And also my members down below. Thank you guys. Thanks for becoming members. I don't know what I got, 4 or 5 now. So you become a patron for as low as $1 a month. The link's down below for that too. And anyway, thanks guys for watching, and we'll see you next time.